Hey everyone, so today we're going to do a different kind of division. It's called synthetic. And let me clear the air on something. I feel as though some of you, after we do synthetic, will be like, wow, this is so much better than long division. Why didn't we learn this first? So let me compare it to something you might understand. In secondary 2 in algebra and stuff, when we do our quadratics, we learn how to factor it, to find solutions to the quadratic. And we also learn the quadratic formula to find solutions. Now, I don't know about you, but factoring to me is a lot more simpler or condensed, less areas to make mistakes than the quadratic formula. The difference is the quadratic formula will always work for any quadratic. Okay, to find any solution for that quadratic. Now, the problem is with factoring is any quadratic you get is not always factorable. So there's limitations with factoring. So it's the same thing with this division we're doing. Long division will work with everything. It will work with all polynomials, okay? But synthetic has to be specific. So even though it might seem a little bit easier, it only works with certain polynomials. The reason what polynomials it works with is linear. What do I mean by linear? Is x is to the first power. So once we're dividing by an x squared or an x cubed, you have to use long division, okay? So here's what we're doing. We have 4x squared plus 3x minus 5 divided by x plus 2. So x plus 2 is our linear polynomial. That is what we're dividing by. So here's how we start synthetic. What you want to do is ask yourself, what makes that linear polynomial 0? So either you have to solve it or look at it and figure that out in your head. So x plus 2, what makes that 0? -2. So this is how it's set up here. I tend to draw an L just like this down. Then what you need to do is put all the coefficients of what you're dividing into on your top line here. So in this case, 4, 3, and -5. Now, just to make it clear, just like long division, if you are missing a term, you must also put a 0 in place of that term. Okay, I'm sure we'll have an example in this lesson for us to go through. So what makes that 0? -2. What are the coefficients? 4, 3, -5. Okay, so how do we do this? Well, that first coefficient, we're going to go straight down. Okay, so I'm going to put that 4 straight down. Then what we do is we take that -2 and we multiply by 4, in this case, that coefficient. So -2 times 4 is -8. So we put that right there. Then what we do, and this is why I like synthetic, is we add straight down, right? We're so much better at adding than subtracting. So 3 plus -8 is -5. And then we do that all over again. We have -2 times this -5. Well, -2 times -5 is 10. Then we add straight down. -5 plus 10 is 5. All right, so what does this mean? This last number here will be the remainder. Okay, and then work yourself back up. The next term would be the constant. The next term after the constant is x to the first, and of course x squared, so on and so on, if we get really big here. So when you write your answer, I'm going to have these coefficients here. So I have 4x to the first minus 5, so right here. And then what we do is we put our remainder, just with long division, put a remainder over what we're divided by. Sorry guys, my nose is stuffed. All right, let's see if we can do that together so you can see it step by step. So I'm going to make my L because I like making an L. As I can see, I'm dividing my linear. What makes that 0? 3. Now I'm going to do the coefficients in front in order. So my leading coefficient or my leading term is an x cubed. That's a 1x cubed. My x squared is a -4. Now be careful here because what's after x squared? X to the first. There is no x to the first, so I have to remember to put that 0 in. So I'm just going to put a star here for your notes so you remember that 0. And then we put in our constant of -5. All right, so remember, next thing we do, bring down that first coefficient, which is 1. What do we do between 3 and 1? We multiply it, put it right here. Then we add straight down. -4 plus 3 is -1. Multiply again. 3 times -1 is -3. Add straight down. 0 plus -3 is -3. 3 times -3 is -9. Add straight down. -14. Okay, I always put this underneath just so I remember that whether I'm forgetting something or not. So this is our remainder, constant, our x to the first, and our x squared. So when I write my answer, I have 1x squared, which of course I don't need to write that 1, right? I have -1x, so I'm just going to say -x, minus 3, which is our constant. Now, it's a -14 remainder. So I either can say plus -14, or I can say just negative and then 14 over what we divided by, which was x minus 3. Awesome. Let's do another one. This one's a little bit bigger, right? Wow, it's getting big here. Okay, so let me make my O. What makes this 0? -3. Okay, coefficients. I'm starting with x to the 5th, so I have 2. X to the 4th is 5. X to the 3rd is -2. X squared is 2. X is 2, and our constant is 3, so we weren't missing any terms. All right. Well, bring our first term down. We have 2. Now we multiply. -3 times 2 is -6. Add straight down. -1. Multiply. Add straight down. Multiply. Add straight down. Multiply. Add straight down. Oh, look, I'm lucky I caught that right there, right? Add straight down. Put a 2 instead of -2. We get 1. Multiply. We get -3. Now, I want to show you guys something. What just happened here? When I say 3 minus 3, we get 0. When the remainder is 0, it means that it is a factor. So remember that when we had quadratics and we talked about factor, I factor a quadratic into 2 binomials, right? And every time we had an x cubed or above, we said, oh, wait, we can't factor it yet. Well, the idea is if you use long division or synthetic and your remainder is 0, that means it's a factor that we can actually pull that binomial out. Okay, so I'm going to show you. First of all, let's finish this up and go remainder, constant. So this is x to the first, x squared, x cubed, x to the 4th. Okay, so our answer to this, the actual division of it, would be 2x to the 4th minus x cubed plus x squared minus x plus 1. And then there's no remainder, so I don't put plus 0 over that. Okay, so this is the division. That's actually dividing. Now, as a side note, though, because this will help you as you go into higher mathematics, as a side note, I can actually say, since it's a factor, that x plus 3 times 2x to the 4th minus x cubed plus x squared minus x plus 1 is the same value as this numerator. It's just factored into a step. And this is how we factor higher terms other than x squared, is by doing long division and synthetic to see what factors we can take out. So that is synthetic. Now, let's talk about the remainder theorem. The remainder theorem pretty much tells us what the remainder is. Okay? If the remainder is 0, that means it is a factor. Okay? So, idea again, we're going to say, hey, is x plus 5 a factor of this polynomial? And we're going to check that out. Now, how we do that is we say what makes this 0, which is -5. And what we're going to do is we're going to evaluate this polynomial at -5. Okay. So we have 3 times -5 squared plus 14 times -5 minus 5. If you guys are using your calculator to do this, which is totally fine, I want you guys to write this out so you know exactly how you're plugging it in and how I know you're plugging it into the calculator. Let's see, so squared plus 14 times -5 minus 5. Okay, plug in that same thing. Okay, equals, and that is 0. So what that means is since the remainder is 0, that means that x plus 5 is a factor to this polynomial. Okay. All right, for B, again, what makes this 0? 3. So I'm going to plug in 3 to my polynomial. I get 2 times 3 squared minus 7 times 3 minus 4. And plug that into my calculator, and I wrote it down so I know that I'm going to plug it in correctly. And we get -7. So this would be the remainder. So in other words, this x minus 3 is not a factor. Now, what's the purpose of the remainder theorem? Well, the truth is when you get into higher mathematics, which I know because I teach it, and I give you a polynomial that's really big, and I said, I want you to factor it. I don't tell you what binomials to try, whether that be long division or synthetic. Wouldn't it be nice to know right away what factors worked and what didn't? Well, one way to check that is to do the remainder theorem. So in other words, for A, I would say, look, the remainder is 0, so it is a factor. Now let me do synthetic or long division. Where in B, if instead of just doing long division and synthetic right away to factor, I would actually test it out first through the remainder theorem and say, wait a second, there's a remainder there. So I know it's not a factor, so I'm not going to do long division or synthetic. So it saves you some time on actually doing those other operations or the division stuff. Okay, let's try this again. What makes a 0? -2. So f of -2, let's plug that in. Be careful of those negatives, okay, everyone? So -2 cubed minus 3 times -2 squared minus 6 times -2 plus 8. Again, I like it when you guys write it down because then you can check to make sure you're plugging it in your calculator correctly. So cubed minus 3 times -2 squared. Be careful if you are not getting the same answer as me. It's probably because you're putting subtraction signs in place of negatives, and that really, the calculator really wants you to define between the two. So when I came out here, I get x is 0. So that means that x plus 2 is a factor. And I would not be wasting my time if I was doing synthetic or long division. It's a factor of the polynomial. Okay. All right, this one got to get tricky, right? Why are we doing so many problems when it's the same thing over and over? Well, again, what makes this 0? So some of you who can't see it right away, you want to make sure that you set it equal to 0 and you solve. So you add 5 to both sides and then divide by 2. So what I'm testing out is this 5/2. So I'm plugging in 5/2 to this polynomial. Those of you who I'm okay with you using your calculators, lucky for you, just write it out and then type it in your calculator. Those of you who want to challenge yourself, try to do this numerically without a calculator and see if you remember all your tricks with your fractions. So 2 times 5 divided by 2 squared minus 5 divided by 2 minus 10. You see that? Okay, equals 0. So what do you know? 2x minus 5 is a factor. All right, try to do some of that practice with synthetic and see about using that remainder theorem. Again, these are some topics that will help you, especially if you go into college algebra.